My name is Cole Perkinson, and I am a chemistry and physics major at Reed College. This summer, I worked at the National Oceanic and Atmospheric Administration, analyzing seawater samples obtained near underwater volcanoes and thermal vents across the Pacific Ocean. My mentor is JISAO scientist Dr. Joseph Riesing.
Chief Scientist of that mission and chemical oceanographer Joe Riesing joins us live right now from Seattle to tell us all about it. Joe, what did you think you'd find when you sent the robot down, and what did you find?
Well, we were hoping beyond hope that we'd see an eruption. I mean, for 25 years we've been searching for eruptions, ever since we knew that most of our sea floor was made from volcanic processes. He is collecting these waters and vapors to bring back to the lab for analysis. There's a device back within the robot that can collect individual samples.
My project focused on analyzing water samples from volcanoes like these to determine their aluminum concentrations. The data from my project was to join a gigantic database of information about the samples, which would provide valuable information about Earth's volcanic processes. In the first week of my project, I programmed an auto-sampling device to inject precise quantities of fluid through a series of tubes to a fluorescent spectrometer. During the body of my project, I used this auto-sampler to measure the concentration of aluminum in seawater samples. The first step in this process is to locate the desired samples. A label on each sample bottle shows whether the sample came from a horizontal tow or a vertical cast, the year and cruise the sample was collected, the cast number, the bottle number, and whether the sample contains the total amount of original aluminum or if the particulate aluminum has been filtered out. Samples are then organized and poured into plastic sample vials. Next, I load the samples into the auto-sampler and pour out standard solutions with known concentrations of aluminum. Based on the voltage readings of these standards from the fluorometer, we can determine the aluminum concentrations of the unknown samples. Finally, we tell my program how many samples to run and the initial fluorometer settings and press start. A few hours later, I return to analyze the data, producing profiles like these. In the final weeks of my project, I worked on designing and testing a new method for detecting aluminum in seawater samples that would produce less waste and be easier to use on board ships. One of the reasons I enjoyed my internship so much is that it combined aspects of computer science, automation, engineering, and chemical analysis. During my time in Seattle, I met great scientists and learned about their work, made new friends, and observed live underwater dives off the coast of Indonesia. I also learned more about underwater volcanoes than I ever expected to know. I would like to thank the wonderful people of JISAO and NOAA for this memorable experience.